Question 15b. The triangle ABC is a right-angled triangle with the right angle at C. The point D is chosen on AB so that CD is perpendicular to AB. The length of AD is P, the length of BD is Q, and the length of CD is H. Show that H equals the square root of PQ. This question may be answered by multiple applications of Pythagoras' theorem. Consider triangle ACB. Now this is a right-angled triangle with AB as the hypotenuse. So AC squared plus CB squared is equal to AB squared. Consider triangle ADC. AC is the hypotenuse of this smaller right-angled triangle, and AC squared is equal to P squared plus H squared. Likewise, triangle DCB, CB is the hypotenuse of this right-angled triangle, so CB squared is equal to Q squared plus H squared. And AB can be expressed in terms of P and Q such that AB squared is equal to P plus Q all squared. So if we go back to equation number 1, I'm going to replace AC squared with P squared plus H squared. I'm going to replace CB squared with Q squared plus H squared, and AB squared with P plus Q all squared. So we end up with this equation here. So P squared plus H squared plus Q squared plus H squared is equal to P plus Q all squared. Now I can combine the like terms on the left-hand side and then expand the perfect square on the right-hand side. We end up with 2H squared plus P squared plus Q squared is equal to P squared plus 2PQ plus Q squared. Now we'll have some cancellation, so this P squared will cancel with this P squared here, and this Q squared will cancel with this Q squared here. So we end up with 2H squared is equal to 2PQ. Dividing both sides by 2, we have H squared is equal to PQ, and therefore H is equal to the square root of PQ as required.